is the head of AI for Stratejos, one of our Australian HipChat add-on vendors, and I'd like to talk to you about AI and chatbots.
I'll just share an embarrassing story about Luke. The first review of the first sort of agenda said NLP, which he carefully put into the process as saying neuro-linguistic programming, which is, making people think things. So let's just try that. You will like this talk. You will. Right. Anyway, natural language processing. Chatbots are very easy to write, and it's very easy to write a really dumb chatbot. Covering off every corner case of what people might talk about is quite hard. So I'm going to talk about how you can do this really simply and without a lot of deep programming expertise. If you've managed to write a small website with a little bit of JavaScript in it, or a little bit of Python, you'll be able to follow this talk. There's no super advanced artificial intelligence techniques. Everything comes from like the 1970s or 1980s, but within 45 minutes, you'll have a chatbot that can be really functional, really useful, and possibly save a lot of time. Now, just to be clear, there's three kinds of chatbots that people talk about. The first are like the slash command that you might put into HipChat. And so it's quite common if you've got an organization with HipChat and Bamboo and so on, that you might create a command in HipChat that goes /build. It pulls your source code out of Bitbucket, compiles it, uploads it, sends an email off to the customer to say that you've fixed the latest bug, makes a cup of coffee. That's a command line chatbot. Not talking about that. The next hardest to write are the task-based chatbots. Now, these have been really popular in China particularly because there's a very clear and universal chat platform. So where in, say, Europe or America, you would just build a web form for people to collect information, it's been quite popular in China to have task-based ones. And so if you've got a problem where the chatbot can control the conversation, so that the chatbot asks you a question, gets an answer, and then asks you another question, asks you another question, and controls the whole flow of the conversation. The typical example is ordering a pizza. I ask you, what sort of meat do you want on it, how big, how many slices. There are a lot of APIs out there for doing that. I'm going to talk about the third kind, the conversational kind of chatbot, where the chatbot doesn't get to dictate the rules of the conversation. It has to respond intelligently to all sorts of stuff that might pop up. And the primary use case for this is customer support and internal IT support. And there are a lot of companies out there trying to do this. In fact, the reason I'm giving this talk is I was doing some work for a startup last year who were building a customer support chatbot. They folded, and I bought off them some of the technology. And I'm going to talk to you about how I wrote that. Anyway, back to companies that are doing chatbot support. I find that there are three mistakes that these kinds of companies make. The first mistake is the belief in the all-powerful and all-knowing Confluence. The belief that if we just look up Confluence properly, we might be able to provide a good answer to some particular chat question. That if the user asks us something, we can go and look it up. And if we can't find it in Confluence, then the more expensive startups will then have, we'll search the whole intranet. And I even saw one startup whose philosophy was, we will actually trawl the whole internet for forums and look for answers there. And the reason that this doesn't work is because most of the time users don't actually know what it is that the problem is. It's like you go to the doctor, you go to the doctor and the doctor will ask you questions so that you can elucidate what it is that's fundamentally the problem. So in the same way, if you try to get the answer, you're thinking about the problem in the wrong way. What you want is the user asks you something on chat. What is the right question that your chatbot should be asking back in order to be able to work further on the problem? The second problem that a lot of support help desk chatbot companies make is the belief that they have to solve every problem. Now, the state of the art is about 90% accuracy. 90% of the time, you're able to come up with a decent response. You are always going to have to include humans in the loop. All you can do is you can optimize what those humans do. You can always make it faster. You can always, make their jobs easier, but you're not going to be able to wipe it out completely. And the third mistake I see in this space of support chatbots is actually a lack of courage in the skills of the developers. That the solution is always Microsoft's API or Lex or Amazon Watson or API.ai or Wit.ai. That all we need to do is just provide a personality and a support capability on top of these platforms. And this is tragically not true as well. What I'll do is I'll give you an example for those of you that haven't seen it before. I'll walk through with Google's API.ai, creating a bit of a chatbot there, and we'll just see some of the things that go wrong. Okay. Now, hopefully I can just hit go and this will play. There we go. Yep, looking good. Okay, so for each different thing that the person might need, we create an intent. So I'm going to create an intent here, which is the problem that's on everybody's mind who's ever watched the movie Office Space. How do I complete a TPS report? Now, it doesn't matter what a TPS report is. In fact, any report doesn't matter because nobody reads it anyway. Don't fill in the report. So we've created one intent. Now we'll create another intent. So this is another kind of thing that some person might be asking. They might ask the question, how do I change my password? And let's make up a silly answer, that the correct answer to this particular support problem is you can't. We do everything by face recognition. So if you want to change your password, you need to have some plastic surgery. Right, we now have our two intents. So as long as the user asks exactly the right question, we can give a response back. So you'll see, how do I complete my TPS report? Answer, don't do it, nobody reads it anyway. Great, correct answer, thank you, Google. How do I change my password? And we can get a response back to that question. You can't. Yep, all good, well done, Google. Now let's give it something a little bit more ambiguous. What is a TPS report? And it's really sure it knows the answer to that. It'll say, don't do it, no one reads it anyway. How do I, which is a completely meaningless question, yeah, we'll still give an answer to that. And it's only when you go like, how? That finally we get that default fallback intent, which is Google's way of saying, I have no idea what this user is asking. And that's only the beginning of the problems. Let me try and explain some of the other things that go wrong. Most of the time, you actually need to have a conversation with a customer or a conversation with the person you're supporting. They will tell you that they've got a problem. You will ask them a question. They'll give you an answer. You'll do some more questioning. They'll give you an answer. And eventually you understand what the problem is, and then you give them a solution. So there's going to be a lot of backwards and forwards. And what you'll find is that most of these platforms, API.ai, Wit.ai, Lex, they're all about that task-based stuff because that's where the market is in China. It's all about just give you an immediate answer, slot filling. But that's not what you're doing in a typical customer support environment. And where it comes into very clear contrast is out-of-order problems. So let's have a flow where I say, I need to change my password. Which password? My password on Confluence. Oh, that's easy. You go up into the right-hand corner, you do stuff. So that's one way you could ask that question. But the user could say, I've got a problem with Confluence. Oh, what problem? I'd like to change my password. Oh, that's easy. Go up in the top right-hand corner and grab the menu item. So the two different orders meant that I had to have two different flows. In fact, I had to have three different flows because there's the other flow where the person says, I need to change my Confluence password. Oh, that's easy. Right, so the problem is that if you try to manually write every single one of these scenarios, firstly, you will be bored out of your brain because there are so many different variations. You'll find it incredibly difficult to get right. You will blow the budget on the project because there's no way that you can do this in any sensible length of time. And you'll make mistakes in it. There's no end of problems as to why manually programming in sensible responses to large chat conversations in this environment doesn't work very well. Now, if only there were some better approach, if only there was a better way of thinking about it. Do you like my neat lead into the next topic? So this is a supervised machine learning problem. Just to have a generic sort of way of thinking about it, supervised machine learning is where I give the computer a bunch of data, and the computer gives me back some rules about how to classify that data. So looking at the rectangle on the left there, I've got a bunch of points which are labeled blue or red, and I've then got on the right, in that sort of contour shape, is the computer coming up with rules about what is the right way of classifying things. So it's saying stuff on the left should be bluish, stuff on the right should be reddish, unless it's kind of in the sort of lumpy bit in the middle, in which case it might be a little bit more likely to be red than blue. So, you probably guessed that I was about to say predicting what you say is a machine learning problem. Now, it depends on the context. There are situations that it's very easy to predict what you're going to say. I don't know why Luke suggested this as an example, but he says on a first date, everybody asks exactly the same questions. Who are you? What do you do? And what do you enjoy? It's only strange people like me that on a first date say, will you marry me? And it's only very strange people like my wife who says yes. Celebrated 21 years a few months ago. In other contexts, predicting what you're going to say is quite difficult. But in support and customer service, it's actually quite easy. And the reason it's very easy is because you always have that annoying user who calls you up every day with the same question, and you give them the same response. Has anybody experienced that? Yeah, good. I'm surprised there was only so few hands up there. And if it's customer support, for a large customer base, you will have tens of thousands of people asking the same question because they're all encountering it for the first time. Right, so what I want to do is take a HipChat conversation and disentangle it so we can look at how we can do machine learning on this. Now, this is a fairly normal HipChat kind of room. There's me asking a question, there's Michael asking a question, then support answers me, I reply to support, and then support talks to Michael Jones, and then Michael Jones returns to support. Now that's a bit of an issue because we need to disentangle that. In order for supervised machine learning to work, we have to have data sets where we've got a question and then we get an answer, or a question, answer, question, question, answer, question, answer. So having these entangled ones is going to mess up the data. There's a couple of tricks that we can use. Trick number one is, because there's that at mention to Michael down there in that support response, that must mean that it's a reply back to Michael. So we can take Michael's first comment out, and if we do that, then you can actually kind of, by elimination, figure out which order the conversation is happening in. But we've also got another little trick that also sometimes works, is that you can guess that it's a continuation by the quick response. So the fact that I responded within a minute back to support with a positive end of sentence kind of, end of conversation kind of comment, like thanks or okay, great, will do, then you can figure out that I must be replying to support, so that support must be replying back to me. And so we can disentangle that and turn that into a number of separate threads. Right, all good. So we've disentangled our HipChat room. Now we need to turn this into some numbers so that we can do some typical supervised machine learning algorithms. Now at this point, there are going to be people in the room who understand natural language processing quite well, have done some machine learning and AI, and you're snickering in the background. Because I'm about to talk about the dumbest technique imaginable. And in a few moments' time, I'll then use that in a yet dumber technique. And the amazing thing about these incredibly dumb techniques is that it is actually working. So let me talk about the dumb technique. And it says something like this. The things that are going to be really interesting in a chat, the thing that's going to give you a clue as to what the person's talking about, it probably doesn't matter about the word order. If somebody raced up to you and said, TPS complete my report, do I how? We would probably still be able to extract the same information from it. So since we don't care about the word order at all we need to know is how many times did that word appear in that utterance. So the bag of words model says I take every word in the English language, or German, or French, or Spanish, plus the acronyms that get used in your company, and I assign a position in a big long list, a big long array. And so if you've mentioned the word aardvark, then, and I have never actually used the word aardvark in a HipChat conversation, but if I did, there would be a 1 in that column, and aardwolf, a 1 in the next column, and eventually we get to the column for the word complete, and there is a 1 there because it mentions that on TPS report, and there's a 1 for the do and the I and the TPS, and then there's so on. Now this is a very, very long array. Roughly speaking, English language, 70,000 words, including all variant forms, so I have an array that's 70,000 elements long. And that I have for each message in any HipChat conversation. So this is a very large very large two-dimensional array. In fact, it's slightly larger than that. One of the things we need to do is we need to predict the next response based on what the user has just said, what the support agent just said, and what the user had said before that, and what the support agent had said before that. So the way I modeled this is I did exponential decay. So after you've said something, it then gets put into memory at half that strength, and whatever was in memory before that gets halved and gets halved and gets halved and gets halved. So looking at that, the 0.25, we're looking at what the user said before that, 0.25, whatever word that corresponds to, I think it was aardvark in my previous example. Obviously, they said that about 2 steps in the conversation ago. If it was the last thing if it was 1 step before, it would be 0.5. If it was just recently, it would have been 1.0. And so that decays away. It means that if you talk about aardvarks, perhaps you're in the zoo or something, and then you change topics and start talking about something else, that mention of aardvarks disappears and just slowly weakens off. Yep. And we do that for what the user said, we do that for what the agent has said, we do that for your most recent things that you've said, and what the recent most thing the agent has said. So putting those, each of those is 70,000 elements long, so we're talking about an array that's 280,000 elements wide, and for every message that you've ever received in that HipChat room, you've got a row. So if you think about it, 10,000 rows, 280,000 columns, you are talking about a very large matrix, but computers can cope with that. And it doesn't even require, say, some massive sort of rent from Amazon 1,000 machines. That's the kind of thing you can do on a laptop these days pretty easily. Now, one of the things that happened recently, I think it was last year, Microsoft Tay was a chatbot that Microsoft released, and within about a day, it was a horrible, nasty, racist chatbot because they didn't really think about who they were training it from. So one of the defenses that I use against this is customers that bring up that as an objection, I say, well, why don't we create a HipChat room specifically for training the bot? So you just go into your training room, give the conversation that you want to have, make sure you don't have to worry about the disentangling, make things really easy. So that's my training room. That is the training data I'm going to use in all the examples I do from here on. Right, moving along. So this is not a very complicated library. The HipChat import library is quite simply just walking through, you go to HipChat, you export the complete history of everything. So I'm just loading that in that first line up the top there. I'm saying the room that I care about for my training room is the room called bot training room. Then the corpus there is read through that export file and look for the user called support. That's who it is that you're going to work with. Then I'll just get it to display the corpus. And these are the conversations that were in the training room. It's removed the users from it, so it's just user agent, rather than Michael, Greg, whatever. And it's come up with these are the 3 conversations that it's learnt about. So here are all the things that the agent has ever applied. The support agent has replied back for which system. They've replied back, choose your profile, and they've replied back, don't bother, nobody reads it anyway. Those are the only 3 responses we've got here. This does scale up to larger ones. Then here are the things that users have said. They've said, how do I change my password? They've said Confluence, they've said thanks, and so on. So let's create a brain. Now that class there, the brain.brain, is just a wrapper around NumPy and Pandas in Python. And here is a display of the data. Once we've done this bag of words model, what you see is just looking at some of the columns. So when the user the thing that the user last said was the word password, here's a column there. So you'll see often the response is for which system. In fact, that happens twice. So what will happen is that the word password will be a really good predictor of that being the right answer. And if we look into the word password appearing in memory, so in other words, somebody has mentioned it previously in the conversation, that's a pretty good predictor of giving the procedure for a Confluence password. And likewise, TPS is a good predictor for don't bother. Similarly, we can look at the word Confluence and see where that appears, and then what we can predict as the next response based on mentions of the word Confluence. Okay. Moving along. Okay, so let's just walk through what's going to happen. This is now the help desk room, and somebody types in a message. Now, this is a message that is not quite right. It doesn't exactly match stuff that we've learnt before. Now, what should I do with my TPS report? I've never done one before. So let's switch over to programmatically. And I've crunched up a couple of those cells just to make it a little bit easier to work with. So monitor the help desk room. Now, I'm polling rather than using webhooks just because of the environment that I'm in here. And I pull out the list of agent names that I'm supposed to respond on behalf of. So it's just the user called support. And in a second, once that's all connected up, let's get whatever the most recent message was, which of course is going to be that thing I just typed. And then, knowing the data we've got, having trained on the data set that we have, we can make predictions. We can say, what is the most likely thing that a human being is going to type in response to that question? So let's have a look at the kind of predictions it would make. So the phrase, don't bother, nobody reads it anyway, probability 35.8% based on the data that we have. For which system isn't quite so likely, and for the answer about fixing up your Confluence password is even less likely. Now, those percentages are fairly close together, but that's simply a phenomenon of I haven't got a lot of data in there. Now, one of the nice things we can do is we can ask, please explain how you reach the conclusion on those predictions. So, first one, which was the don't bother, nobody reads it anyway. We concluded that because of the word report, that is a really good predictor of a human being responding with that particular answer. So it's got a reasonable strength there, and it appears. The word TPS is another good predictor. The word my, on the other hand, is a very good negative predictor because it's my password usually that defines. So when we added it up, it came up with like 0.07 points towards this being the correct answer. What other answers? It might have given the answer for which system, because the word my is a really good predictor of that. The word report, however, really negates that as a possibility, and TPS is a really strong predictor that that's the wrong thing to respond with. Likewise, giving the answer to how do you reset your password in Confluence is very unlikely to be associated with a question about TPS. So therefore the answer is don't bother, nobody reads it anyway. One of the awesome things about extracting the rules that you're getting here is that this can form the basis of your frequently asked questions that you put in Confluence. You know the key words that people are using in the sentences that you are replying back to. So just dump out some of the really common, strongest keywords, the words that are really good predictors, put them up as keywords, and when people search, they're going to use that same vocabulary and they'll hit those kind of search results. Okay, let's put it all together. So I've got that first cell is the stuff from about 2 slides ago. Then I've got the next, so that's where my mouse is at the moment. Yeah, that's from 2 slides ago. Then I'll just run that, grab the data, then choose the room that we're going to monitor. That was what we did in the previous slide. And then here's just a loop. And the loop goes like this. Infinite loop. Let's just wait, poll every 5 seconds to see what messages there are. Just grab it. And if we're waiting for the user, then there's no point in us saying anything more, so we'll just step back. Pull out the predictions of what a human being would normally answer in this particular context, and choose the most likely one, that's predictions number 0, and print out the result just so you can see and debug what's going on in this environment. And if it's confident to above 0.25, so 25% confidence, then we'll display it. Obviously, you would change that number in production. You might wait until you're sort of 75% confident, and send that message back and put a little printout message. On the other hand, if you aren't confident that you've got an answer, then just punt, wait for a human being to come in, and then you can learn from that human being's answer. Okay, so let's see it in action. Somebody asks, I'd like to reset my password, with some other text in there. And the chatbot will then, within 5 seconds, come up with some sort of answer to that, for which system seems a very sensible response that a human being would give. Then Confluence, and then, of course, we can immediately give the answer to that particular flow. We're using the fact that they mentioned password, the fact they used Confluence. Here's the logic. So we responded to, I'd like to reset my password with for which system, and it was 39% confident that was the right answer to give in that context. And then the next one was, in responding to the password in memory plus Confluence in being the last thing said, we're 43% confident that the correct answer to give in that situation is the password reset instructions for Confluence. Okay? That was fairly quick, but let me just summarize what we've done. You take a bot training room, you pay an intern to type in things that have been asked in your support environment or from your customers, and you put in what are sensible responses, and that's it. And if you want to correct an answer, just put more stuff into the HipChat room. If you want to force a particular answer as being really common, just put it in the HipChat room a whole series of times so that it becomes really common. And you do not need to do any further programming. This will scale out to thousands of different responses. It doesn't matter whether your users are asking, when do I put the garbage out? If you've got answers to that question, if people have been giving answers to that question, if support people have been giving answers, the chatbot will come up with Tuesday night. Now, I've skipped over a number of different bits and pieces here. Firstly, the model I use, which is called the bag of words model, it's not the best. The only reason I use it is because everybody in the room hopefully understood it. There are some better techniques. You just look up Wikipedia for TF-IDF or BM25. That's a little better weighting. Another common technique is called the word-to-vec technique. So instead of ending up with a 70,000 element array, Word2Vec lets you shrink that down to something sensible. Like if there's only maybe 300 different topics that get talked about, then you could shrink that down to a 300 element vector. The way I did memory there, where I had like that exponentially decaying, this is what's been talked about in the past, is probably not state of the art. State of the art is what's called a long-term, short-term memory neural network. There's a fabulous course called course.fast.ai if you're interested in learning how neural networks work and how LTSM works. Now, it's traditional to have a conversation, a talk end with a "and one last thing." So let me just summarize what it is that we've been doing. We look at HipChat conversations or whatever chat conversations you have in mind, and we can predict the next thing that somebody's going to say. But machine learning lets you predict lots of outcomes. It's only a question of how much noise there is in the signal and whether or not it's genuinely predictable. So I did an interesting project just recently. We looked at the chat conversations going on around a large number of software development projects. Have any of you been involved in a software development project that is really, really going off the rails? What's wrong with the rest of you? Just any project that's going disastrously? Did you know, those of you, the 4 people who have always put their hands up, did any of you notice that your conversations in your chat rooms changed? The tone changed? The words you used changed? The speed at which chats went backwards and forwards, the amount of discussion? So, that being the case, can we predict a project being in trouble from chat conversations using exactly these techniques? And the answer is, yeah, we kind of can. And I think the implications of that are really quite dramatic, that even without doing anything special, we can get artificial intelligence-like applications to act on behalf of our support desk people, act on behalf of project managers, act in a whole bunch of roles that have traditionally been protected white-collar jobs. So I'm running extremely ahead of time because I talked very fast because I'm nervous. So thank you to everyone. And I guess you predicted I was going to say that because it's the end of the talk. So questions?